need a picture.
Can we take a picture?
You're already going out of
No, we have to
No,
take a
I
picture.
lost my keys. I don't know where they are. Check the scene set.
the bathroom, your pocket.
I have my card.
We have to
It's
take
in-
a picture. I told Zane.
I remember the keys being on the desk.
You can take off the mask. Yeah,
I'm gonna pass down.
yeah.
Or someone steals my car keys. I'm so glad you're wearing a tie today.
Of course, I'm wearing a tie.
You
Do I
don't
have
have
to
a tie
go
there.
right now?
Ever since the masks came off, I wear ties again.
Whenever you want.
How are those? What?
I hate them both. So as long as I was wearing one, I refuse to wear the other. So,
Okay.
You don't like ties?
not especially.
I'll take your ties.
But you know,
I don't like them.
they add one more way for me not to match with myself, so it's good. Hey, should have played basketball instead of soccer. All right, so move it over. Today we're going to look at weird situations with limits. Example that one. If we try to do integral direct, not integral. I'm off today. If we try to do the limit directly, we get e to the negative infinity times the square root of infinity,
Positive.
and
Positive. Oh, I'm blind.
yeah,
Sorry.
that's fine. We're off today. So what's e to the negative infinity going to be? 0. And what's the square root of infinity? Infinity. And what's 0 times
We
infinity?
don't know.
Yeah. So it's like we don't know who wins, the 0 win or infinity win. So this is an indeterminate form, but it's not L'Hopitalable. So to try to make this fit something better, what can we do?
Divide x over e to that.
Yeah. So we say, oh, we got this negative exponent. So let's try throwing e to the x down the stairs. And try again. So now if we plugged in infinity, what would we have?
Infinity.
Infinity over infinity. All right, well, we still don't know what it is, but at least now it fits L'Hopital's rule. So we can try L'Hopital's rule. And on top, what is the derivative of root x? 1 over 2 root x. And leave that whole thing in the numerator. Like you could say, oh, it's 1 over 2 root x, so put the 2 root x in the denominator. Don't do that. When you take the derivative, leave the whole derivative in the numerator, and you'll see why in a second. And the denominator, what's the derivative of e to the x? E to the x. And now try again. So if we plug in infinity this time, what do we have in the numerator? 1 over infinity. Now what's 1 over infinity?
It was something.
0, right? So 1 divided by infinity, that's a regular thing divided by infinitely many ways, that's 0. On the bottom, e to the x is going to be infinity. And what's 0 divided by infinity? 0. Because if you have nothing and you split it up a lot of ways, you still have nothing. So, what? Now, you could have done that, but I think part of the reason we were getting weird stuff yesterday and getting a vicious cycle was... Good point. So that would have also worked. Yes. I'm off my game today, so you're also correct. Yeah, we could have bopped this and done that. But this works too. Any questions with that example? So if you have indeterminate form that involves multiplication, like in this case you had 0 times infinity, try flipping something by switching the exponent to positive or negative or vice versa. We'll jump over to example 7. Because examples 5 and 6 are awful. And so we might have to push those off to Monday.
Why are we doing that?
Because we need to. Because I do enjoy tormenting you. And if we get to that today, then so be it. But, no, I never do those.
Yeah.
All right. So here we have a subtraction situation. Guess what we're going to end up subtracting? Probably infinity minus infinity. Let's find out. So, as you approach 1, ln of 1 is 0. And if you're approaching 0 from which direction? The right. So 1 divided by the right side of 0 is? So what's 1 divided by 0 going to be? Something undefined is going to be some kind of infinity, and specifically it's a positive infinity because we're approaching 1 from the right, and therefore the natural log of x is approaching 0 from the right. So that little detail is actually important. It tells us which infinity we're approaching. So this is going to be a positive infinity. Then 1 over x minus 1, if we're approaching 1 from the right, what is the denominator?
0.
On which side of 0 are we? Positive side, because we're approaching 1 from the right. So 1 minus 1 is going to be 0 on the right side. So that little nuance that we're only approaching 1 from a particular side makes a difference into terms of which side of 0 we're approaching and therefore what kind of infinity we have. So 1 over 0 from the right is infinity, and we're subtracting it. And so you have another indeterminate form. We have infinity minus infinity, and we're like, I don't know. That could be anything. It could be 0. It could be like 7. So how do we determine what to do, or what it is we go back into the original function, and in this scenario, we have separate fractions. Try to combine them together. So this is get yourself a common denominator and combine. So again, one of the things that makes calculus difficult is that at any moment you might have to do something from any previous math ever. So this is like 4th grade math all of a sudden. Get a common denominator, and you got to recall that. Yes. I mean, maybe not with x's and stuff in 4th grade, but yeah, but this is kind of putting stuff together, so it's like normal. Partial fractions where you take something and pull it apart. So you forgot to drop the marker while you were up here too.
I did throw it.
You did throw one across the room?
I didn't change it to end the class.
Sure. So what's our common denominator going to be?
ln of x times x minus 1.
Yeah, ln of x times x minus 1. Set them apart from each other with parentheses so there's no confusion of like accidentally sneaking x minus 1 in the natural log. And when you get that common denominator, what's the numerator of the first fraction going to have to be? And what's the numerator of the second fraction have to be? Negative ln of x. All right. And now you clean up. No, you don't. There's nothing to clean up. And let's try again.
So you made me write all that previously.
What?
I wrote 0 minus 0 over 0.
Yeah.
0 over 0.
So now you can't clean it up.
That's so
So I said clean it up, and then never mind. If you try to plug in 1 now, what do you get in the numerator? What's 1 minus 1? What's the natural log of 1? So what's the numerator? Yay! On the right. And in the denominator, ln of 1 is 0, and that's times 0. And so we have 0 over 0. So what can we do? L'Hopital this. So you combine things together into a single fraction. You try to take the limit. It didn't work, but it gave you a 0 over 0 situation, so you can L'Hopital, and you go ahead and do that. What's the derivative of x? Of negative 1. Poof. Of ln of x. 1 over x. Now here, you really can't throw x into the denominator because it's just a single term. It's not the whole numerator. Downstairs, be very careful. Do we have to do product rule? Yeah, we do. Because we have to take the derivative of the entire denominator as a unit. Shut up, you. And the denominator as a unit is a product. So we do have to do product rule down here. So derivative of the denominator, product rule says do what?
Derivative of the first guy.
Yeah, derivative of the first guy, 1 over
Second
x,
guy.
times the second guy, x minus 1.
Plus the derivative of the second guy.
Derivative of the second guy, 1. times the first guy, ln of x. Beautiful. Know your product rule. Because suddenly it pops up and you're doing it in the middle of a limit. Now you look and see, does this work for us? What's 1 minus, that's 0. Uh-oh. And over here we have
1 times 0 plus 0. It's just
0
0.
plus 0. Oh, bother. Does that mean we need to do it again? Maybe.
Product rule? Oh, well.
Wait. You know if this is a loop?
Well, actually, no. You can just
I'm pretty sure it's not a loop.
So you got it from the book.
Yeah, I got this out of the book. So, can we clean this up at all? Yeah, let's try to maybe clean this up. So we got 0 over 0. We could just go right ahead and do L'Hopital again, but maybe it's worth trying to clean this up a little bit. Maybe instead of like we're going whole hog clean this up, you can at least just like deal with this thing right here.
X minus 1 over x.
So
Yeah.
nice. I hope you guys didn't spend a lot of money on this.
No, I
Okay.
just had this stuff and it worked out.
Good. So x minus 1 all over x. If you split this up, what do you get?
1 minus.
1 minus 1 over x. X minus 1 over
There you go. That's what I was trying to get at. So you divide that out. X divided by x is 1, and 1 over x is 1 over x. So you'd have
Oh, wait.
1 minus 1 over x plus the natural log of x.
Divide that, and then you get 1 over L.
Can't you cancel? Never mind. I'm stupid. I'm sorry.
You can cancel
You can't.
Now.
Because they're being added down bottom, so you can't cancel.
These can't cancel out because is this multiplying the rest? No, so it's not a factor. But would it be worthwhile to multiply by an x?
Can you separate the?
Like multiply by x over x? So I have like multiply by a fancy 1?
Sure. Go ahead.
Okay, let's try that.
But then you would have 2 ln of x, right? Because it'd be ln x, right? If you multiply by ln x.
No,
Or would that be
x
x times ln x?
Yeah, it'd be ln of x times x.
So
So
it's
then
x
it'd
ln
be
x.
x to the power of x.
So it's 1 times.
We don't want to do that. We want to leave it at x ln x. Well, what if we just did the L'Hopital's rule again? Like we already know that works because we got 0 over 0.
1 minus 1 over 1. 0.
So,
0,
yeah, right?
0.
So 1 minus 1 is 0. 1 minus 1 is 0. Ln of 1 is 0. So it's 0 over 0. We could just do L'Hopital again. Or we can say, you know what? I don't want to deal with a fraction within the fraction. Let's multiply by fancy 1 and disappear that. What do you want to do? L'Hopital or fancy 1? Fancy 1 had like 2 votes to 1 fancy 1 vote. So let's do the fancy 1 vote. I think I misspoke there, but whatever. All right, so multiply by x over x. What's the new numerator?
X minus 1.
What's the new denominator?
X minus 1 plus 2 ln of
Not 2 ln of
x.
x.
ln of x ln of x.
X ln of x. And you're still going to get 0 over 0. But at least now doing L'Hopital's rule will be a little bit easier because you won't have like fractions within fractions.
Can we cancel the ln of x?
No. The x ln x is not going
That's
anywhere.
what's yielding.
I know, it's what's annoying us. So, sorry. We'll bring this up over here. We have the limit as x approaches 0 plus of x minus 1 over x minus 1 plus x ln of x. Move the camera.
We have to differentiate that?
There it is. 4 point Javier. Javier 4 pointed. Everything's a verb. All right. So that's 0 over 0. L'Hopital it. When you L'Hopital this, what's the numerator? 1. Hooray! That's not going to give us 0 or infinity. So maybe that's a good thing. In the denominator, we have
1.
1, nothing, product rule again. So when we do product rule with this, John,
1 times ln of x.
plus 1 times ln of x, and plus x times 1 over x.
So 1.
So that x over x cancels, and we have
Plus ln of x.
1, and then that's 1 plus 1 is 2 plus ln of x. This looks promising. So we have 1 over 2. So in this case, infinity minus infinity is a half. Of course it is. Yeah. Yeah. So to kind of come back and summarize everything that just happened. We tried to do the limit directly. We had infinity minus infinity, so we don't like it. Then we take the two fractions and we combine them together into a single fraction by getting a common denominator. We tried to do the limit again, and we got 0 over 0. So we L'Hopital. Because the natural log of 1 is 0. We're approaching 0 from the right because we're approaching 1 from the right. So 1 divided by 0 is a positive infinity there. We're approaching 0 from the right here for the same reason. 1 divided by positive 0 is infinity. And we have infinity minus infinity. So infinity minus infinity leads us to try to combine these together into a single fraction. Do the limit again. That gives us 0 over 0. That leads us to do L'Hopital's rule. We take the derivative of the top. Fairly simple. We do the derivative of the bottom. Product rule, be careful. We try to do the limit again, and we get 0 over 0. We simplify the denominator a little bit, and then multiply by fancy 1 to get rid of the whole fraction within a fraction business. And then, because that was 0 over 0, we differentiate top and bottom again, do another round of L'Hopital. Again, be careful with product rule, where you have that in the denominator. And then now, finally, we can do the limit and we get a half. So there's a lot of and then going on there. Any questions with any parts of that example? The computer?
Yeah. The laptop?
I mean, I'm recording on this screen, so this doesn't really matter, but I don't know why. All right. Time for ugly.
We should do example 5.
It looks like we're on example stuff.
Yeah,
Can we just wait?
That's aptly named. All right, we're just gonna leave it there. And do you want sine of x to be x, or
Wait, what was that?
sine of x all to the x, or 1 plus 1 over x
1 plus 1.
all to the x?
1 plus 1 over x.
Sine x. Yeah, I think it's not sine x.
Okay,
1 plus 1.
We're kind of learning.
we'll do the other one on Monday probably.
I think I should learn. I want to do this one. And then it's also like a fraction.
All right, so sine of x to the x.
Sine of 0. 0 power.
You try to do this directly. What's sine of 0?
0.
0 raised to the
Can't do that.
0, and we don't know what that is. Because 0 to the anything is what?
0.
But anything to the 0 is 1. So who wins? The 0 base rule or the 0 exponent rule? No. So in this scenario, this is indeterminate. We don't know what this is going to be because we have two hard, fast rules that are coming into conflict with each other. So we have to figure out a way out of this jam. Now, this is where we have to get real clever and create a new variable out of thin air. What should we probably call this variable?
Double
V for I was going to call it Y, but we can do V. I don't care. So we say we're going to take this whole limit and say, hey, you're going to be equal to V. Why? So that we can find the limit. And then, once we've done that, now you take the natural log of both sides. So you, what? So you turn this into an equation. You say, I'm going to define this whole limit as V.
The limit part of the
So the limit is part of your equation. You're defining the entire limit as being V, whatever V is. V is just a variable. And then, whatever you do to one side of an equation, the goal is to make this an equation so that you can do stuff to both sides. So whatever you do to one side of an equation, you got to do to the other side to keep things fair and balanced. You're going to do the natural log of both sides of this equation now. So you're going to say, all right, let's do the natural log of V, because why the hell not? And over here, we'll do the natural log of the limit. We have natural log of V, That's just going to just sit there and be that for a while. And over here we have the natural log of the limit as x approaches 0 plus of sine of x all to the x. No, it's the limit of this stuff. Now, guess what we can do with the limit and the natural log?
Cancel.
Swap them. So you can take the limit out.
Why?
Because if it's the limit of this thing, it's also going to be the limit of the natural log of that thing, as opposed to the natural log of the limit. So the natural log of the limit will be the same as the limit of the natural log.
So you counted that they're being multiplied.
So in the sense that it's commutative, yeah, you can use your fake commutative property and say, yeah, swap them. So this is going to be the limit, and then the natural log of sine of x to the x. And why do we want that? Because we want the natural log to be of this stuff, so that what can we do with this stuff? Get the x out. We want to get the x out of the exponent. So when we have one of these weird situations where it's 0 to the 0, or 1 to the infinity, or something like that, one of those indeterminate forms that's an exponential, we want to get the exponent out, and the only way we do that is with a log. So that's why we did the logarithm in the first place. So our next step is going to be bring the x out, so we have the limit, as x approaches 0 from the right, of x, natural log of sine x. Meanwhile, this is natural log of b. And then we're allowed to do a derivative, even though this is not a L'Hopital situation. And why are we allowed to do a derivative? Because we can, because we're not going to just do it here. Where else are we going to do it? On the left side, because it's an equation now. And as soon as we've made this into an equation, we have so much more freedom to kind of do whatever we want, as long as we do things on both sides. So we can do, maybe a derivative would be useful here. Oh, okay, I'll just do the derivative on the other side to keep things legal. So what's the derivative of natural log of b? V prime over v, because we decided that v is a variable. And over here, we do the derivative of this stuff inside the limit. And that's going to be ugly, because that's quotient and product rule. Chain rule, not quotient, no quotient rule. Chain rule and product rule. So, because sine is inside a natural log. So, product rule, derivative of the first guy is 1 times the second guy is natural log of sine x. Plus, the original first guy is x times the derivative of the natural log of sine x is not 1 over sine x, cosine over sine x, because derivative of the inside over the inside. No, that's your integrated. All right. Then, no.
I saw you.
Where'd the limit go?
Thinking about it.
I forgot to write it. Limit. Of course you would say. So you say anything is board point whether in your mind.
How am I supposed to know? We're still taking
No, you're right. You're right. I gave you the board point.
Oh, I see it.
All right. So we have v prime over v.
Wait.
The limit as x approaches 0 from the right. We might run out of time with this example, which would suit me just fine.
So
Let's get these together into a single fraction.
Keep the door closed.
Well, maybe, can we do this limit? What sine is 0? Or do we know the natural log is 0? No, we don't. All right, let's get these together into a single fraction.
ln of sine of x times sine. Sine
Yeah.
x ln sine x
Sine x ln of sine x
plus x cosine x over
plus
sine
x cosine x all over sine x.
x. So it's 0 times.
Now, if we do, well, if we try to take this limit, sine of 0 is 0. Sine of 0 is 0. What's the natural log of 0?
It's going to be 0 anyway.
It's going to be negative infinity. So we have 0 times negative infinity plus 0 over 0. Let's assume this is locatomic rule.
We should come back to this.
And then we'll come back to this on Monday. Because this is leading into real ugly land. Right?
We gotta think.
But Michaela still needs to do her
Yeah.
Edgar impression.
Yeah.
We have multiple things to do.
So there's my out.
It's okay. It's Friday.
It is Friday.
Oh, wow.
I'm tired. All right, so Michaela, go.